Hello and welcome to yet another lecture on quantum system. Myself Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Degree Engineering College, Electrical Engineering Department. So we have already know about the mathematical modeling of a physical system, mechanical system that is called the spring mass dashboard system, along with the nodal analysis, followed by the voltage, force voltage analogy and the force current analogy, and the transfer function that we have obtained from a that is called the electrical equivalence circuit of a mechanical system, followed by the rotational motion, transfer function of a rotational object, that is a rotational motion that we have also designed, and then followed by the torque voltage and the torque current, or in other terms, it is called the force voltage or force current analogy. So today we will discuss some numerical problems related with the mathematical modeling of physical system, and from there we can easily obtain the transfer function. So let us start. We can start with a problem that is called the nodal analysis. We have to obtain the transfer function using the conception of nodal analysis. So a mass is there, a spring is there, followed by a dashpot, and it is connected with the rigid body. So this is B, and spring constant is K. So where the displacement can be written as x1, where the displacement can be written as x2. So we have to find the transfer function using the conception of nodal analysis. We have to find the transfer function. So if I visualize that particular model, there is no force in this system. So the output here is the transfer function is the output by input, keeping all the in the Laplace domain, keeping all the initial conditions equal to 0. So output is the displacement x2s. The displacement is occurring. There is no force in this system, so its displacement is occurred due to the this input. For this particular x1 is displacement, the corresponding x2 is displacement is occurred. So the transfer function is x2s by x1s. So let us do the nodal analysis. In order to do the nodal analysis, it is generally known to us that how many nodes we will consider. Number of displacement equal to. So we are doing the nodal analysis. So first of all, we have to think about that. How many nodes are we have to consider in case of the nodal analysis? So in case of the nodal analysis, we are doing it is number of nodes. How many nodes we have to consider equal to number of displacements. So how many displacements are there corresponding for the nodal analysis method is number of nodes equal to number of displacement. So here the two displacement is there. One is called the x1 and then one is called the x2. So here the number of nodes will be 2. So let us take in 2 nodes. One is known as x1 node and one is known as x2 node. So between x1 and x2 there is a k only. So we just put k here. The spring that is connected between x1 and x2. So this is called a reference node. So nothing is connected with x1. Now in case of the x2, that is aim is connected. So I just connected the aim with x2. Followed by a dashboard B is connected with the x2. So I have just connected a dashboard B. So you can also consider a dummy force at x1 F is there. This is a dummy force body. F is there in order to obtain, so that you can easily obtain that. We can consider a dummy force, but if not be considered, we just only take a straight line to draw the x1 point. So let us add node A1, at node x2. So what is there at node x2? If I draw the equation, that will be aim into dd2 of x2. You can easily write there dt square plus b into x ddt of x2 plus k into what is the resultant displacement? X1 means the mass is moving in that direction. So the x1 is moving in that direction, and x2, the displacement, x1 displacement is in that direction, so the x2 displacement is in that direction. So the resultant displacement will be x2 minus x1. Because why it is x2 minus x1? Because when it is come back to its initial position, the resultant displacement will be x2 minus x1. Okay, when it's come back to its initial position, the resultant displacement will be x2 minus x1. Now I am taking the Laplace, giving all the initial conditions equal to 0, will be a square m into x2s plus b is b into x2s plus g into x2s equal to a into x1s. what is x to s by x1 s? So our transfer function, that is x to s by x1 is by x1 is, using the conception of taking all the initial conditions equal to 0, it is k by m square plus bs plus k. This is our transfer function. Using the conception of nodal analysis, we can easily find the transfer function of the system. Using the conception of nodal analysis, where there is no external forces applied to the system, but still we can find the transfer function, that is the x2 displacement is occurred due to the x1 displacement. So x2 is by x1 is, so we can easily comment on the transfer function using the conception of nodal analysis, where the number of nodes equal to number of displacements. Now we will discuss another problem related to force voltage analogy or some force current analogy. Now let us take another example in order to understand the force voltage and force current analogy. So first of all, we have to remember that particular part. In case of the force voltage analogy, if one part is remembered, we can only concentrate on the another part. Where force is generally equivalent to voltage, mass is equivalent to inductor, dashpot of the damper winding is equivalent to resistance, spring constant is equivalent to 1 by C or the capacitor, that we have to remember. And what in case of the force current? In case of the force current analogy, it is very much force current analogy or FC say analogy. It is very much that the voltage became current, that is force is equivalent to current. Okay. It is very easy to understand that the L will become C, means M is equivalent to C. So the L becomes C. B is equivalent to R. It will remain same. The R will remain same for the force current analogy. K will be equivalent to L. So that is the force current analogy. K will be equivalent to the L. So here C will replace by L. L will replace by C. B force voltage is replaced by R, and a series branch, that is the series branch is replaced by parallel, will be replaced by parallel. The series will be parallel, series branch, and the parallel branch will be series. So vice versa case. And the parallel branch will become series 1. So AL will be replaced by C, C will be replaced by L, series will be branch will be replaced by parallel, parallel will be replaced by series, and voltage will be replaced by force. So let us take an mathematical or mechanical system, the physical system, in order to obtain the force voltage and the force current, and that is the electrical equivalence. So the force is applied to a system. Transport is there, that is called V2. Spin followed by a mass followed by a dashpot. That is V1, that is M2, that is the K. And here the displacement X2, and the displacement is X1. So in order to find the nodal analysis, number of displacement equal to number of nodes that we have seen just. A number of displacement equal to number of nodes. First, in case of the force voltage analogy or force current analogy, number of masses, number of masses equal to number of loops. So how many loops we will consider? There are number of how many masses are there in the system. So in this case, there are two masses are there. So the number of loops will be two. Okay. So let us first come to the force voltage analogy. Force voltage analogy of that particular system. So you can easily first just draw the there are two masses. So we just draw the two loops first. Just draw the we just draw two loops first. I'm drawing just two loops. This loop for M1 mass is very much this loop is M1 mass and this loop is for the M2 mass, so that it can easily be understood by you. And this common part, this is for both M1 and M2. This is called the common part. Now, with M1, a force is connected. Means with M1, the force is there. With M1, the force is connected. So force is replaced by the voltage. So force will be replaced by the voltage. So I am putting a voltage source here for a voltage. Next, first force is replaced by the voltage. So I am putting a voltage source here. Next, B2 is connected with M1. Just concentrate on the B2. Just concentrate on the M1. Which portions are connected? The force and then the B2. B2 means It will be replaced by resistance R. So just connected and resistance R, that is called the R2 in series with the voltage source. Connected in resistance R2 in series with the voltage source. Now, between M1 and M2, between M1 and M2 means this common area, only B1 is connected. So B1 means a resistance R will be connected. So connected a resistance that is called R1 between B1 and B2. So connected and resistance R1. Now, this is the M2 part. With M2, first there is and another thing is there with M1. M1 must be replaced by M1 must be replaced by M must be replaced by L. So M1 must be replaced by L1. That will be also connected in series. We can write R2 L1 here also. Now we are writing L1 here. We can also write R2 L1 is M1. We can also write R2 L1 here. R2 in series with L1. We can also write in that way. We can also write this is R2, same. This is L1. Okay. So next is the M2. First M2 will be replaced by the L2. So write down L2 here. There is M2 that is replaced by the L2. Followed by a K is connected with M2. So K must be replaced by C, the capacitor C. K must be replaced by the capacitor C. So it is replaced by the capacitor C. And that is why we can able to complete the entire force voltage analogy. Can able to complete the force voltage analogy, and it will be the capacitor C. Or I can write it as a C2 also. Now I am going for the force current analogy. Force current analogy. So first will be the voltage will be replaced by the current source. So here voltage is replaced by the current source I, followed by second portion is series branch will be go to the parallel branch. So in series branch there are R2 and N1, so they will be go to the parallel branch. R2 will remain R2, R2 will remain R2, but L1 will be converted into L will be converted. Capacitor will be converted. The inductor will be changed to capacitor, and the series branch that is now converted into the parallel branch. So it is C1. Both R2 and in L1 are connected in series, so they are now converted into the R2 parallel branch first, and the R2 will remain R2, and the L will be changed to C capacitor. Followed with this R1, it is connected in parallel. So means this R1 will come here as a series branch. This R1 will become here as a series branch. Followed by this L2 and C2 is connected in parallel, so they in connected in series, so they will come as a parallel branch. So first L2 will be replaced by first they are in series branch, so they will become as a parallel branch. So L2 will be replaced by C2, and followed by C2 will be replaced by C will be replaced by L, and L will be replaced by C. So this is called the L2. So here we can able to draw the force current analogy from the force voltage analogy. So this is the force voltage and force current analogy of a mechanical system. That is the electrical equivalent of a mechanical system. So today we have discussed the mathematical problems related with the physical system, the nodal analysis conception, and the force voltage or the force current analogy. That is the in order to find the electrical equivalence of a mechanical system. Thank you.